Hello, and welcome to the Distributed SQL Virtual Conference. In this session, we will explore Envoy Service Mesh and how it intersects with the database world. Introduction, this is Prasad Radhakrishnan, VP of Data Engineering at Yugabyte. And with me, I have Christoph.
Hello, my name is Christoph Pakulski, and I'm software engineer at Tetrate and recently been contributing to Envoy in Postgres area.
So before we get on to Envoy, let's look at the direct and indirect dependencies of an application.
Correct. So let's see that you try to develop an application, and the application wants to. It's not really contained application, though it means it needs to fetch some data, either to read or write or store somewhere outside of that application. So in order to make this fully resilient, someone when your users and clients will be happy, you really would have to implement several, I would say, availability methods. So one would be to find where your server is, and I call it a service discovery. You really just want to start, and it automatically finds one endpoint, more endpoints, so you can do so you can have more than one server. And on top of this, once you can find the server, you really want to talk it and detect that things are going wrong. So you have to detect that there is a timeout. You have to also detect that your server went away. It's not available anymore. Either the server could be down, or maybe the routing changed and the routers cannot deliver the packets. What also can happen is that the server could be overloaded at some point. You send your application or the other application talking to the same server, they can easily overload the server and server will start returning the errors. So you somehow would like to cut or maybe even limit the number of requests you send to that server. You would like to also know whether that server is replying with what you want to reply. So you send a request and it returns, success, saying that it could read the data you wanted or the wrote data you wanted to write. Also, you would like to balance. So you would like to have more servers. Maybe you want to use the load balancing when the server goes away, or maybe you want to send one request there, the second request to the other instance of your server. And you would really have to implement all those things in your application, which is very complicated. On top of this, if you distribute SDKs, so one, for example, for Golang, for Python, Java, C++, you name it, you would have to implement all those things in every single SDK. It takes a lot of time, a lot of QA resources, debugging, etc. So Envoy basically takes care of all of those problems. And your application would really have to maintain just one connection to Envoy. You just send it to Envoy, and it's programmed to do all of those things. It can discover servers. If the servers becomes overloaded, it triggers a circuit breaking. You can limit the rate. You can also program it to find out whether the servers are alive or not. Has a couple of different load balancing methods, like round robin, can choose the server which is, which accepts the least request at any given time. There is a couple of load balancing algorithms which are kind of sticky. We call them consistent hashing. Can also program retries. The retries means there is usually exponential back off. The first retry happens quickly, but if the server does not reply, you can increase the time it tries next, and that's all programmed in the server. And what it gives you that your application and developers working on the application concentrate purely on the business logic, not on the network delivery part. That would be shifted to Envoy. So that's all on my side.
Awesome. That sounds magical. Let's see how the magic happens. So what is Envoy?
Okay. So Envoy is a layer 7 proxy. So by saying, what does it mean a layer 7? So if you look at the stack of, ISO stack, which are the different layers of networking stack, layer 7 is basically the application. So it has to understand your application. Let me give you an example. So that would be, for example, HTTP, right? So when you really talk to your web server, you have to format the HTTP header and the payloads, so it really is way higher than the delivery layer. Delivery layer is basically contains only information how to reach the server and how to come back to your client. However, layer 7 proxy understands what that packet actually carries. So I gave you an example of HTTP, but we'll be talking here about the Postgres. So that in case of Postgres, Envoy would actually understand what kind of operation in Postgres language you would like to do. And also when Postgres database or Postgres compatible database will reply, Envoy will also understand what was in this message, whether it was a success or not. We will talk about it in detail later on. So it's a self-contained process. Basically, when you compile, we get a binary. And you can couple it with your application in several ways, but two of them are very important. So one of them is that, like I explained before, that your app just talks to Envoy via IP. So it could be co-located on the same host, or it could be hosted on the other host. Most important part here is just that the delivery between application and Envoy, that connection is on an IP layer. And so it relies on IP routing tables. And when application sends it to Envoy, it just gets the IP address and it goes. The second, I would say, positioning of Envoy in relation to your application is so-called sidecar. And that creates a way, tightly coupled pair. And Envoy kind of like intercepts all the traffic which goes to your application before it even reaches the application. And we do it depending on the operating system, but Linux, we use mostly IP tables. So IP tables, somehow the routing stack thinks that it delivers to the application, but Envoy kind of like steals it in the fly before it reaches the application. In that case, your app is really talking to outside web, to Envoy. It doesn't really know about that. Okay. It also contains the filter mechanism. So what does it mean is the filter? Filter is once you receive it, is something which provides an extra processing on top of delivery. So in some sense, Envoy, you can say, is just a router. It looks where to deliver the packet, but that filter is something you want to do on top of just the delivery. You want to do something, basically a critical component of mesh. It's basically a data plane of mesh. In a mesh, all the applications will be very tightly coupled with Envoy, and Envoy will take care of network delivery for every single application or microservice running in the mesh. So like I said before, it has a couple of methods for LB. So why it matters? So like you want to load balance, you want to send an application, request to different endpoints or upstream servers, but you might have some extra requirements. So if you really don't care where it goes, you can use a simple round robin. So it means that every time your application goes, the next server is chosen. You can put a little bit more extra logic into it and say, I want to choose always the server which currently has the least number of connections. So I always choose the one which is not as busy. But you can complicate it more, because you may say, yeah, from this client, I always want to hit the same server. So it's not really any server, but if this client is talking to a upstream server, I always want to reach the same instance. So in that case, you can name it like a stickiness. So in that case, you have to use a different algorithm for load balancing, and we called it consistent hashing. And the list of Envoy features is a way longer.
Picked a few of how Envoy is being used, different patterns in which Envoy can be used from the documentation, right? So there's like 4 different patterns that we have here. Can you quickly touch on what these 4 are? What's the significance? And what purpose does it serve?
Yes, that's a great question. Start with the right part. It's simpler to understand. So that's something which we called front load balancer, basically. So if you look at the top right, there is a couple of services. We call it here service A and B, but it also could be a fleet of your servers. And Envoy basically is just the entry point towards them. So your application, your clients, they basically first hit an Envoy, and Envoy will deliver to one of those services, service A, service B. That Envoy is pretty much like a standalone process And it really doesn't matter where it sits. It could sit on the, might be even co-located with service A, might be co-located here with service B, or maybe sitting on some separate node, or it could be even co-located with your client.
So Christoph, so would you say, so the one on the left side, here Envoy serves the purpose of a tier 1 load balancer?
That's correct. That's perfect naming. Yes, exactly. So it's just an entry point to your fleet of data. Exactly.
That's right.
So it's not really tightly coupled. I said that it could be co-located, but it's not really tightly coupled. It's just, you talk to Envoy, and Envoy talks to services, to backend services via IP. The right bottom, you basically create like a hierarchy of envoys. So, there's a T1, and then there is a cascading structure, which, you forward to another envoy, and this another envoy knows about services A and B and can do a proper load balancing. It's just a little bit more complicated than the front load balancer, but the idea is exactly the same. And the most important part is not really tightly coupled with the application. On the left side, bottom and top, you see that service and proxy are very tightly coupled. In this scenario, we treat services and Envoy as a kind of like a one unit, and the traffic between them could be unencrypted. There is the same, I guess, security domain, which we treat as inseparable, as parts which cannot be really separated, right? And we trust.
It's more like a Kubernetes deployment pattern. Like within a pod, I have 2 containers.
Exactly. Usually the typical deployment is that both of them, service and Envoy, they run in the same pod. Exactly.
How do we get started with Envoy?
Okay, so that question actually, shows up quite often. The best way of using it is to use it as a front load balancer. So there are 2 ways. You can either compile the binary, or maybe take a Docker instance, which is published by Envoy community. The other way to do is to use a get envoy. That's a utility developed by Tetrate, and it maintains certified builds of Envoy. And the way it works is that you have to specify which flavor, which version you want, and it automatically downloads the version you want, and also can automatically bootstrap the config depending on a flavor. So it's way easier to do versus creating your own config from scratch. All right, so now is interesting thing. So now we're going into a mesh, and like I said before, it's a little bit more complicated how you do it, because proxy and application or service, it's very tightly coupled. So when would you use a mesh? So usually when it happens, when you go and you would like to kind of decompose your application into some smaller pieces. And we call those services, microservices. It's just a small application which serves a very limited functionality. And now they can talk to each other using, they basically have to somehow communicate between them. And they use it using, nothing stops you from, somehow programming the delivery layer and talking to them without any proxy. But by doing in a proxy, you do a lot of things. So it's not only, like I said, that you automatically get all those benefits like load balancing and, retries, you do all those things, but you can program very sophisticated things. One of them, most important, are the security thing. So for example, if service A wants to talk to service B, we can automatically encrypt the communication between 2 proxies which are attached to those services. But also we can also put the access control. So there might be a question, okay, service A wants to talk to service B. Is it allowed? And then there will be an answer, yes or not. If the answer is yes, obviously they create secure connection, they can talk. If the answer is no, the connection never happens. So, and that happens automatically. You don't have to really program into either service A or service B. It's programmed directly into a mesh. The other thing is that when, there are applications which has been decomposed into 100 of microservices, And that becomes really complicated. And if you want to know what happens between, different types of microservices, is very hard. But the fact that each of them has an attached envoy allows us to extract, some statistics and data for observability point of view. And we would know that what is the traffic pattern here, right? You can also do a so-called canary deployment. So let's say I have a service B and I would like to put another version, which I'm not really sure how would it work. So I can introduce that service B1, the next version of my service B, and instruct envoys saying, you know what? Let's just only do, for example, 1% of my traffic to my next version of service B, and let's see what happens, whether it's gonna to work or maybe it will fail, so I have to redo it again. So all these things are programmed into an envoys. So the natural question is, sure, fantastic, but how do we control it? It's fairly complicated. So then when service mesh, and in that case, Istio comes in, when there is a control plane which is specifically written towards controlling the fleet of Envoy proxies. And it's not only, it can distribute the routing tables, like I said, the percentage of the traffic which should go to the next versions. You can extract some statistics from this. From security point of view, encryption between envoys works based on TLS, and authentication is mutual, so both of them need a certificate. So also this control plane contains a certificate authority, and quite often, in a matter of minutes, refreshes the certificates for all envoys which are involved in the secure connection.
So Christoph, just for clarity, so from the control plane, now we could push, any changes to access control, or, let's say there's an application talking to a database cluster, any connectivity information about the database cluster. Now all those things we could push down to the data plane without having to restart the apps or redeploy the apps. Is that a fair thing to say?
That is absolutely correct, and this was one of the reasons why Envoy was a great candidate for Istio. So what happens is that we can send the dynamically envoys constantly keep the connection to a control plane, and whenever there is a change, we send it down. The Istio sends it down to envoys, and Envoy automatically reprograms itself. So if you want to add extra endpoints, you put another instance of your database and you would like to route it there because you scaled it up, you can easily do it by plugging in that information into a control plane, and it will automatically send into all instances of envoys. So now I will take a minute to talk about Tetrate service bridge and in what kind of situations it can help. So imagine that you start from scratch. You don't have any legacy product, and you can start designing your app, in a clear paper. So you would like to decompose it into a nice microservices and place them into a service mesh, and everything is good. But it rarely happens. So during this process, you will face a couple of problems. So first of all, that certain part of your application runs as a microservices and the other runs still in your VM, for example. And how do you bridge it? How do you manage it into some consistent fashion? The other situation would be that you have a couple of meshes, and you deployed part of the application in one mesh, and the other part of the application is running in the other mesh. TSB, a Tetrate Service Bridge, brings you this unified control plane which can manage all those situations. Exactly, thank you. So you will basically see your application regardless, in a nice unified way, regardless how it's decomposed. You can have a one VM and a mesh, and you will nicely see it, and you will have the same naming for similar things. So service meshes works on the idea of, for example, services, and you will still have the same meaning, even if part of them runs in a VM. So important thing is that, observability or telemetry. And again, you will exactly get the same thing, regardless where it works. And in Tetrate Service Bridge, TSB is intelligent enough to know whether your application or part of application has been deployed, is it on the cluster or VM, and extract the information you need. On top of this, it can extract the policies. And like I said, if you have a, part of this running on one mesh, the other part running on a different mesh, you would have to do a security policies and access control in a kind of separate way. One on mesh number one, the second on mesh number two, and have to maintain them separately. So TSB will basically bridge it. And it will allow you, if you want to do certain policies, similar policies, we will just distribute it on both meshes. And you also can build the access control policies, and TSB will manage in a similar fashion across more than one managed service mesh. The other benefit is that you can carve for multi-tenancy. So, you can just divide the roles and set the application which belongs to one tenant running on a mesh and somehow, share the same resources with the other tenant. And TSB will nicely recognize those and kind of separate and will understand what's required for tenant one and tenant two, and will apply the policies, depending how you configure those.
Okay, now let's switch our focus back to Envoy and look at some of the internals of Envoy as it relates to Envoy and database interaction.
So let's clear up some Envoy terminologies so it's easier to understand official documentation and also to understand how it works. So the basic terms are basically downstream and upstream. So the connection, usually there's always one side which initiates the connection and asks a query or asks the request. So from endpoint point of view, there will be our downstream. When Envoy talks to a server to initiate that connection, and that's what we to actually fulfill that request, and that will be an upstream. So the listener is something which it's very common to any network application. It's basically IP. TCP and slash IP and TCP IP port. So, we're listening on a maybe specific interface on this port, and that's where Envoy expects to receive the request from the client. And then there is a set of filters. We said that once we have that connection, we read the data, then it traverses multiple filters, and those filters are configurable items. So maybe even 0 if you don't want to have an extra action to do. But each of those filters do a specific operation. They usually inspect what's in the body of the request or response, but it has to really go and filter by filter, and they may do different things. They may produce some metadata. They really understand the protocol which is currently being passed over that network connection. In some cases, there is a filter which provides the role-based access control, so it can actually look and say, hey, no, this request is not allowed, so it may not forward it, allowed to forward it any further. And there is a concept of cluster. So cluster basically understands, it has a knowledge about the upstream endpoint. So we said that the load balancer usually is a very integral part of delivering in terms of Envoy. And the cluster not only knows about the endpoint, but in the real time really remembers, knows which endpoint is currently healthy. And so, how many connections are currently served by that endpoint. It can keep track, whether it's healthy or not, and also applies the load balancing algorithm. And this whole set of things related to connectivity upstream, we called it, it's called cluster.
Now, let's say now I have an application that's got an Envoy sidecar, or even if Envoy is going to be the front proxy, one way or the other, I'm connecting to, let's say, a database, and let's say it's a distributed database with multiple nodes, right? So you would refer to that as cluster endpoints, the different nodes of the Yugabyte, different nodes of whatever the database might be. You would refer to that as cluster endpoints.
It's not only that it knows, but you can program into a little bit of logic. So it's not only that you have, for example, 2 instances of a database, but you can say those are 2 instances where I prefer to go. I might have another 2 instances of the so-called secondary, which cluster may not use until it needs it, and it needs it when the primary nodes goes away. So, in the cluster is not only the knowledge about what's there, but you can actually build some logic saying, those are preferred and those are not. And Envoy cluster and load balancing algorithms, they can shift the load when the primary nodes goes away. So, but answering your question exactly, in case of Yugabyte, when you have a couple of nodes, because a distributed database, like you said, you have a couple of nodes which create the logical database. Yes, they will have to program them into a cluster, and cluster will know about all of those endpoints. So yeah, so that's actually a tricky part. So let's start on the left. So that's something which is called a static config, right? And it's written in the YAML. It's kind of touchy. So what I mean is that why I call it touchy, because it really is very sensitive to a syntax here. It contains all those things we talked about. So, as a listener, there is something listening on a backend loopback interface on a port 1968. There is a filter chain. So in this example, I use the Postgres proxy, which runs on top of TCP proxy. And at the end, you really have a cluster. And in a cluster, it should actually add a couple of endpoints. It currently is not listed here because of the space. But usually here you will list all the endpoints you have, and there's a couple of methods you could do. You could just statically put static IP addresses. You could put the one DNS names, which will resolve into several IP addresses. Really different methods, but here it will list, where are your endpoints or servers which you would like to Envoy to talk to. In service mesh, we actually use a different method. So different method writes that it's used gRPC to communicate from control plane to Envoy and push the initial config, and then incremental config updates. When anything changes in a control plane, it will be pushed towards the Envoy, and Envoy will take it in an incremental way.
So both accomplish the same. The one is static, you configure Envoy. The other one is Istio from the control plane, you're pushing the config down to wherever your sidecar proxies are running. That
is correct. All right, so we touched a little bit on what the filter is. So imagine that Envoy accepted just the connection, and you would like to do something extra on this. The good example is looking into the body of the message. And that's what the filter is. Basically, is that extra operation which is on top of just the delivery. And as you see here is several examples of network filters. And you can, for example, see echo. Echo is good because you send a message, filter captures it, and replies with exactly the same body which was sent. There is a Kafka broker which understands Kafka protocol. There's MySQL proxy, which understands MySQL, or Postgres proxy, which understands Postgres language. And there is a very set rich of filters which are geared specifically towards the HTTP traffic, right? And here is an example. The list is way longer. We just show here just a fraction of this. And the full list is in official Envoy documentation. So here I would like to talk a little bit about this PostgreSQL network filter and what does it really mean. So like we said that Envoy initially accepts the connection from the client to, and the connection which eventually will go into the Postgres Postgres compatible database. And once we have that connection, there's usually a body traveling with this. It could be, because this is an example of a database, it might be a query, it might be a result of the query, it might be an error. So it's just a sequence of bytes. The important thing is that at that point, Envoy have to have access to a clear text body. It cannot be really encrypted, right? Otherwise, Envoy wouldn't really understand it. And it really has a knowledge of Postgres messages. So Postgres messages are very well defined. There is a documentation, official documentation. So first byte is usually a type of the message, then there's 4 bytes of length, and then depending on the type, there is a different syntax of each message. And Postgres network filter really understands those messages. So for example, if application wants to do some select, just execute the select, Envoy will know about that, and I will you know, we'll demarshal it, we'll understand, say, hey, you know what, here, I see the request for select from a specific table. And when the replies comes, it will see whether it was successful. So yes, we did it. I know here is a reply and it was success. Or if not, there was an error, it will know, you know what, there's the previous, the previous request which went resulted in error. And it's the same for all different Postgres transactions. So we'll do insert, update, and Envoy is able to decouple that. And what do we do with this? Right now, you can do two operations. One is that producing statistics. So when you see that as the transactions goes back and forth between the client and the server, the statistics are increased. Then, you know, number of messages, front messages, backend messages, number of inserts, number of updates, number of errors, number of commits. And so it really can produce a real runtime statistics depending on what the composition of the traffic between the client and the SQL server. And because the Postgres runs on top of TCP, you have to stack it that it runs on top of, there is a filter, and delivery part would be a TCP proxy. So you stack it that way, and you take care of delivery and also take care of decomposing and producing a stats. The other thing which we can do in this thing is producing a metadata. So metadata is kind of extra information which is attached to this Postgres message. So for example, the good example would be an operation, some kind of SQL statement. Metadata would be if you do a select star from something, metadata would be that this packet contains just a read operation from a specific database from specific table. If it was a write operation, kind of insert, it will tell you that this data, this packet carries write operations towards the specific table and a specific database. And there is a couple of things you can do. Right now, what you can do, you can, for example, program the next filter in line, the access control filter saying, I do not allow any writes into a database. And it will immediately stop and never even reach the database. That's how is one of the examples you can use the metadata.
A few minutes now to blend in Yugabyte here and how Yugabyte's PostgreSQL compatible interface, how that's going to now work with Envoy, but we'll also make it a little interesting. So I'll do a quick overview of Yugabyte, and then I'll talk about a couple of deployment options of Yugabyte and how now with Envoy in the mix, what this means, what are some of the challenges today, and how Envoy can look to sort of help in that scenario, right? So quick overview. So Yugabyte, basically a Google spanner-like architecture brought to life in open source. It's a distributed SQL database. In its crux, Yugabyte has what we call DocDB. It's a distributed document store where there's sharding, load balancing. It uses Raft consensus for how replicas are maintained, how transactional guarantees are provided, etc. Also has a distributed transaction manager. That's in the foundational layer, which we call it as DocDB. And then we have one SQL compatible interface, which is YSQL, and a NoSQL interface, which is called YCQL. So in one database, you have multiple APIs, and one being Postgres compatible interface. Now, one on the left side, what you see here is your standard Postgres, where you have the query layer on top, and then there is a Postgres storage layer, and it stores data in its local disk. And Postgres, as we all know, is a single node database. Now in Yugabyte scenario, what we have here is the query layer of Postgres is pretty much available in every data node of Yugabyte. So it is just the query layer because foundationally Yugabyte uses its distributed document store for storage. So we are wire compatible with Postgres. So we get all the benefits, which is a case in point in this discussion is that now Envoy, while the community worked towards getting Envoy to work with Postgres without any additional modification, now it is able to work with Postgres with Yugabyte as well, which we'll see in a little bit. But to sort of sum it up, each data node of Yugabyte has Postgres query layer, but underneath it stores data in a distributed manner. Now what you see here is two different deployment options, right? Let's take the one on the left side. Here, this is the default installation topology of Yugabyte where one would install it across failure domains of your choice, like AZ, region, or cloud provider, or in a hybrid cloud topology, etc. So in this scenario, Yugabyte can afford to lose any one failure domain completely, but the database would be still available and data is still kept strongly consistent. What you see on the right side is what we call cross data center asynchronous replication. So this is the scenario where two different Yugabyte clusters are asynchronously replicating data with each other, either unidirectionally or bidirectionally, doesn't matter, but they're replicating data. It's installed across three, let's say, AZs. Now you do get to set preference, as in, if you say, I have a preferred AZ, AZ1 is my preferred AZ, and AZ3 is my second order preference, then what happens is Yugabyte will push all the tablet leaders over to AZ1. What we want the application to do is, by default, establish connections with the data nodes in AZ1, right? So usually, what we do in the scenario of where we use the Postgres API of Yugabyte is we would configure the load balancer in such a way that first preference would be to the nodes of AZ1. It would send all the requests to nodes of AZ1. And if in case AZ1 is down, then the load balancer would have been configured with AZ2 as the second order preference. But if there are going to be more nodes added to the cluster, let's say I start with a 9-node cluster, 3 each, and then I expand it to a 12-node cluster, 4 each, then it is either semi-automated or manual to be able to go and update the load balancers, right? Now let's look at the other scenario, the other topology, where it's like two different Yugabyte clusters. In here, let's just call it an active DR cluster, right? As in, you want the cluster on the left to be serving all traffic. If should something happen to cluster on the left, then you want the traffic to cut over to the DR cluster. Now, since we would have set up asynchronous replication between these two clusters, data would have been replicating to the DR cluster. So now the apps would connect to DR if the active cluster goes down. Now, as you can imagine, even in this scenario, we'll have to go make some modifications to the load balancer, right? Either to the driver or in the load balancer or DNS. In one of these, 2 or 3 places, you have to make these changes. So now the app is able to connect with the cluster that is alive, right? Now towards, we'll switch over now to a small demo, and then towards the end, let's, sort of bring this back and discuss, what is it that Envoy can do today and what is it can look to do tomorrow or in the future.
On the back end, we have 4 different nodes of Yugabyte database running in the cloud. I have a couple of queries which I'm going to execute, and everything will happen through Envoy. And I will demonstrate that Envoy actually understands what happens between the client and those instances running of Yugabyte database running in the cloud. So if you look at that, at the config, I define exactly the same pieces which we described before in this presentation. So I have a listener which I named, gave a name Yugabyte, and it's listening on the loopback interface on port 1968. And then I have a filter chain. So like you said, those components which will process the traffic as it passes back and forth. So obviously I set that Postgres proxy because we are using Yugabyte database using Postgres compatible API. And as a delivery method, we'll do a TCP proxy. What's interesting is that the cluster will have those 4 different nodes which I mentioned. So those are the nodes and DNS names for those, all are running on a default Yugabyte port 5433. And I'm going to use a round robin, but I have to mention that the round robin is per connection, not per transaction. So if I do, if I connect to the database, it will be this one TCP connection, connect to one node. The next time I will do it, another connection, it will connect to a different node, but not per transaction. Once I connect, all those inserts and selects will go to the same node. So once I have this config, I'm going to start, we start Envoy with a trace logging, so you will see that a lot of is going on. It understands the processes, the messages passing through. So I'm going to use a PSQL client, and I disable SSL, and I'm going to use certain SQL statements, which I'm going to pass. Okay, so now I execute a set, the dropping table, and as we can see on the right part of the screen, I'm going to query using a specific HTTP endpoint for a statistics, and I can filter it out saying I want to only Postgres filter statistics, and you will see that every time I query, there is a different number saying. So for example, at this moment, there were 97 messages passed between back and forth, and from this there was a 67 which are backend messages, and there were 30 front-end messages. From this, this part basically create the tables which we wanted, and I will go back to my PSQL client, and then once I have those tables, I will start feeding extra data. So I'm executing this, and here we go. So on the top, the screen flashes very quickly, but you will see that every time a message passes, that Envoy actually decrypts it. It say, hey, this is a front-end message. It's insert into this database, into this table, so you can see it at the specific debug log level. And if I go back and start dynamically asking Envoy what's going on, you will see that right now we have about 2,500 messages. There were 773 inserts. There were no deletes. Altogether, there was 818 transactions. So it really spits out those statistics really per Postgres message type.
This is basically statistics collected at the Envoy level, right? So, I'm not doing anything on the database layer to understand who fired what, but right there in Envoy, we are able to tap into it and generate these statistics.
That is correct. And there's a couple of things you can do with this. So for example, you can export those in Prometheus format and use any time series database and portray it nicely in Grafana. And if you have more than one Envoy, you can aggregate and say, in my entire cluster, that how much traffic, was passing through a fleet of Envoys, not only one. So we can actually export it from more than one Envoys. And like you said, we don't have to do it at the database level, at the application level. It happens on at the delivery moment. So it finished, and I can actually look back. There was a large number, about 7,000 messages, more than 10,000 messages in total. There were inserts, no deletes. I will do exactly the same, but in Get Envoy. So
Christoph, this is basically, what we discussed at the very beginning, the easiest way to get started with Envoy.
That is correct. In Get Envoy, so there would be an example on the Get Envoy, and maybe it's not visible clearly, so I will quickly go saying what you have to do. So you will invoke Get Envoy application and say, I want to run a Postgres flavor, and you have to really specify just the two things. One would be list of endpoints. So here I specify the Amazon instances and port. So it's this long Amazon type name. And I'm using two endpoints here. So you really have to, mostly copy and paste here in one line. And the other parameter which you really have to specify is that would be the listening port, on which port we want to listen. So I'm going to use exactly the same port, 1968, I used in a previous example. So really, there is really no syntax. You just specify the name of your endpoint. It could be IP address, or it could be a DNS name like I'm doing here, plus port, and on which port you want to listen. And that's all. Once you start, it basically, if it's not locally available, it will go to a server maintained by Tetrate, and it will download the Postgres, the image which supports Postgres flavor. It will automatically choose, so you don't have to really worry which one is there. and automatically will create config and plug in those things which were passed in a command line. So it will be listening port, and it will be the list of endpoints. And now if I go again into my PSQL client, I can run exactly the same transactions, and I'm getting the same thing. I can query Envoy and the same endpoint, and I'm getting the same statistics, and I'm getting. So
this is terrific. So both the scenarios here, which are running live, one is PSQL client through Envoy connecting to Yugabyte. The other one is a sample Java app that is using Envoy as a sidecar and connecting to Yugabyte.
No. Both of them are running as a front proxy. The only difference is in the first one, in the first scenario, I had to, have locally available. The first thing I had to have locally available binary of Envoy, and I have to myself craft the proper config. In the second thing is I say get Envoy. I want to talk to those endpoints, and I just want you get Envoy to bootstrap config, download from the server the proper certified image of Envoy, and start running it. So there is way less things to do. Don't have to worry about the proper config because get Envoy automatically creates that config. We just have to do an absolutely minimum amount of information, which is the list of upstream endpoints and where do we want to listen on the where Envoy will accept the connections from PSQL. So in both cases, the result is exactly the same, that PSQL client can talk to Yugabyte instances, and you can gather statistics from endpoint at the same thing. So it's just the easy of use and automatic bootstrap of configuration if you use a get Envoy package.
So now let's extend our thinking to sort of, brainstorm, where can this evolve, right? Where can it get to, right? This is like 2-month-old development in Envoy. Is that fair to say?
Yeah, I think the very first version which was of Envoy, which was released with Postgres filter, was version 1.15, and it was released, I believe, in June/July. I don't exactly remember the date.
Ballpark, yes. It's been only a couple of months. So now that said, so today there is no TLS between Envoy and database, right? So it has to be clear text, but that I would think certainly is in the near future.
That is correct. So looking from a, okay, so let's talk about the TLS maybe for a minute. So nothing stops you from starting the transaction from your client, going through an Envoy and, hitting your database on the backend. It's totally possible. There are scenarios when there is the front proxy scenario, which we talked a lot during the presentation, and behind that is kind of like a trusted network. And we want to terminate the TLS right at Envoy, and everything behind would be a clear text. So that's something which we currently work as we speak. There is an open item, and it's under active development. So the encrypted part will extend from client and will end at Envoy, and later on Envoy will talk to a database. Another, kind of spin on this would be different, that application talks to Envoy in clear text, and then Envoy, when it wants to talk to an upstream database, will use a TLS. So the terminology we use for this is an upgrading connection, and there are other filters which actually do it. So that's the TLS part.
Got it. Now, I think what the other one that was very interesting, that's why I brought up a couple of the topology options, deployment topology of Yugabyte. So the outlier detection, while we didn't really, dive deeper into what is outlier detection, I'm sure maybe some folks are familiar with it in Envoy, how it works. So I think, using that, for Envoy to be able to handle some of those topology considerations, like how do I work with the preferred region or AZ that I might have, and the other scenario is, hey, if one cluster, the active cluster fail, for some reason is unavailable, how do I do a failover to the DR cluster? I would think that is something you could tap into the outlier detection of Envoy and try to make that happen, right?
That is correct. So when you have a load balancing mechanism in the back end, there's actually two parts of it. So one of them is balancing the algorithm itself, between the healthy nodes. But the other part is that how do you know which nodes are healthy and which are not? So somehow the load balancer has to learn, which nodes are still healthy and which are not. So there are usually two mechanisms for that. So the one is specified here in the below saying active health check. So what it means? It means that Envoy basically periodically sends some request and server response. So in case of HTTP would be that some URL which so Envoy asks, get the response, say, hey, you're healthy, I'm satisfied with you, and its load balancer will treat it as a healthy node. If it fails, it will remove it from the pool of healthy nodes. Outlier detector is actually a little bit different because it only observes what's going on, whether the upstream server replies in a correct way without sending any extra traffic. So the good example would be, for example, HTTP. That let's say that there is a server and it's totally fine, but every time you ask, it replies you with an error, like internal error, internal error, internal error. So you would like to, even though it replies, but it's not the node which you think is healthy. So you would like to eject it from the pool of healthy nodes. So this mechanism currently exists in Envoy. The problem is that in order to say whether the response is correct or not, there must be, the Envoy has to understand layer 7 body syntax. So in case of our example here in this, in this presentation is Postgres, we have to really understand whether replies coming from the server are legit, whether the syntax is correct, whether it constantly replies with some valid data, not some random data. And so if it happens, you basically would like to catch the situation when server is online, it's there, but everything you send there, it replies with an error or garbage or maybe even empty thing. So there would be an outlier detector. I said the mechanisms is there, it's just had to be fed from a module which understands the syntax of messages.
Larger sort of purpose of Envoy and Mesh is to, in some sense, simplify how application is written, right? You want to keep the focus more on the business logic and remove everything out of the concerns of application and application developers. So the CQRS design pattern, basically in its crux is about, can I send the read queries to one instance of the database, but the write queries to a different instance of the database? So it's kind of, some folks have tried to implement it in different ways, but Yugabyte does support the asynchronous replication between clusters. So now if Envoy could sort of, intercept the query and, okay, this is a read query, I'm going to send it to cluster A. This is a write query, I'm going to send it to cluster B, right? If Envoy can play a role here, this now enables a CQRS design pattern.
That is correct. So that's something on the, I don't want to say roadmap, but the way to do it is to produce a metadata. So let's say that there is some SQL state, in a message, there is some SQL statement. Mm-hmm. So there needs to be a parser which looks at that and produce kind of extra information describing in a very concise way, what is it? So it will basically, for sake of this, this question would be, this is a write operation for this table or, in this database. And that it travels further up through the chain of filters and into a cluster. And that metadata is attached basically to that piece of data inside of Envoy. And later on, it may be used, when actually the routing happens, when the upstream cluster is chosen. So like we said, there's only one, there is really no question, but there is more you can say, you could try to program it saying, if it metadata attached to that packet or message says is a write operation, choose, node or from this pool or specific node. So there might be somehow described that try to choose those writes or give the preference or maybe always write to this write. So there we might have to write some logic saying,
Right.
use those nodes for writes.
Yeah.
Correct.
No, I touched on CQRS, but actually there's a ton of things we can do if Envoy could, read a query and determine which cluster, should receive this request. For instance, if there can be certain kind of queries that don't really need consistent view of data, so that can be routed to a different cluster. And if there are certain kind of queries that does require, strongly consistent data, it goes to the main cluster. So there's a ton of design patterns or benefits we could derive out of, routing based on queries. If Envoy could do that, that's great. So in the best interest of time, moving on. So the other one is Postgres or database specific active health checks. So every database, as we can, imagine, has a way of doing health check to understand whether that particular database is up or, how healthy it is, etc. So to be able to implement that. So Envoy, in that layer, then we can determine what needs to be done if the, backend database is unhealthy.
That is correct. So that's something we talked about it, a few minutes ago, that you can probably do even now the very basic checks, like, on a TCP level, that someone is listening on a specific port. But to really judge whether your server is up, you really would need to understand what was the reply. So you would really have to understand the syntax of the message returned for your active health check. So it definitely is a fantastic, piece of data to logic to put inside of the filter. So, and then use it in a very specific way. So you can answer the question: is my upstream node healthy, in a very precise way, versus using some very generic mechanism like TCP, for example.
Yeah, makes sense. Now, then the last one, I believe that is, going to be something we can do already, based on what you demonstrated, is to sort of, or maybe we can do latency. Can we?
Yeah, I see what you're saying. So yeah, you can do it. In some sense, you can do it. So you can periodically, once every few seconds or whatever your resolution is, you can ask Envoy and say, what, give me your current stats, how many inserts, update or deletes were currently passed, and kind of produce a graph. And yeah, you can do it, but the resolution is not really great. But what we're talking here is that we can really measure up to a milliseconds, or maybe even a better resolution. How much does it take for me to do for the Envoy to deliver and get a response for insert or for the update, and then produce the aggregate statistics with this. And
there's a ton of things that we can pile up here, and and keep asking for new features to be developed on the Envoy and the mesh side. But this is certainly a very, very interesting space to look out for and see what the next round of enhancements and features that are going to come out. And for the attendees, if you're interested to follow the communities involved here for Yugabyte, obviously you can go to yugabyte.com/Slack. You can join the community Slack channel, and also the GitHub link published here gives you a view into what is being worked on in Yugabyte, the open source database. And if you want to know more about Tetrate, please visit tetrate.io. And for Envoy, there's a Slack channel, and specifically there is an Envoy Postgres channel in the Envoy proxy Slack. So if you want to sort of get updates more so on the Postgres side, please sign up for that. And again, Istio has a community Slack as well, if you want to sort of stay up to date on what's happening with regards to service mesh. So Christoph, this has been fun working with you in the last couple of weeks to put these materials together, and I learned a ton of things from you. So thanks to you, and thanks to the attendees of Distributed SQL Summit.
Great, thank you.